Hello everyone, and welcome everybody to the webinar about how to teach ROS fast. So in order to and welcome everybody to the webinar about how to, in order to get to follow the title of the webinar that says how to teach ROS fast. Let's go fast to the introduction. And then the first thing I would like to say, my name is Ricardo Teller. I am the CEO of the Construct. It's the company that is providing this webinar. And I'm going to talk today here about how you can create a course of ROS. How can you teach ROS to your students in a very simple and fast way? So a more efficient way of teaching ROS. And this is the summary that we are going to talk. First, I'm going to explain you why ROS is difficult to learn. Then I will give you an overview of the method that we have defined in order to teach ROS fast. Then I will show you a step-by-step guide about how you can implement this method by yourself in your own schools, in your own universities, whatever. And then finally, I will show you some implementation options that already exist, so you don't have to implement everything of this method. Okay, let's go for that. But before we start, let me tell you that for all of you who wait until the end, you will receive a PDF containing a step-by-step guide, instructions of everything that I'm explaining here. Bear in mind that this webinar is going to last for 30 minutes, so we don't have a lot of time to explain. So in this PDF, you will see a more detailed way of how to implement this method by yourselves. So I will give you the instructions about how to achieve this by the end of the webinar. Okay, let's go. So why is ROS difficult to learn? That is the main reason. So we have figured out 4 reasons for that. The first one is that students do not have access to the robot. And then we strongly believe that people doesn't learn things because somebody else is explaining those things to them, but we do learn things because we practice those things. And this is especially important for robotics, learning how to program robots. So you have to have a robot, and because robots are so expensive, so difficult to maintain, then students have limited access to them, and that is why this is making more difficult to learn ROS. And what we are following here is an approach that is called the constructionism. That means learning by doing. Okay, second reason. Okay, so this is very important, is that ROS is difficult. This ROS is not a simple concept that you can learn just by reading a book and that's all. Concepts are difficult, and especially there are too many steps and concepts that the student must master before they can create something that produces a result. And how we learn is by practicing things, seeing the results, and then closing this loop in a way that the result makes sense to us. But if there are a lot of steps between my practice and the result obtained, then this loop, closing loop, it's very long, and then it's increasing the time that I need to learn something. This is called that we have a delayed reward in what our actions produces results. Then the third reason is that the material that we use to learn ROS is made by teachers for teachers. So it's like the teachers are not creating learning material for the students. So they think that they will understand everything that they have written in their material in the same way that as they already know, the teachers. So that's what I call the reference material. And let me show you what I mean when I say reference material. So let's imagine that this is the whole knowledge of ROS that the student has to learn. Then most of the teachers that teach ROS, or most of the tutorials that you will find on the internet, what they say is that they go to the last layer of the knowledge, then select the beginning point, and then they teach you everything, every single concept that is related to that layer. Even if you are not going to use some of those concepts until 1 year from now, but they teach you everything. Now, when everything has been taught on that layer, they go to the second layer and then repeat the process. Then go to another layer and repeat the process, and so on until you reach the core of ROS. Okay, so we don't believe that this is a good way of teaching. And now I'm going to show you the method that we do believe that is a lot more effective for teaching complex subjects, not only ROS, but we apply here to ROS. And our method is based on this book that is called The First 20 Hours, that I highly recommend to anyone to read. Then the first step of our method is to deconstruct. What this means is to figure out which are the basic building blocks that describe ROS. So we are going to find, the teacher has to find which are the basic blocks that compose the whole ROS material that has to be learned, okay? Then on the second step, what we are doing is we are removing many of those building blocks. We are only taking into account those blocks that are the most important ones. Only the blocks that produces some results in the short term. It is like if I make some similarity with what I have said before, is imagine that having the whole lot of ROS, we don't start at the last layer of ROS, but instead we start in the center, at the center. And then we select the red area, that those are the blocks that we are going to teach, and we move from the center to the last layer. So by doing this, the student is learning the most important parts, only the ones that produce the fastest result for what the student wants to do. That is maybe to control a robot for doing something. Okay, then the third step in our method is to learn by testing. So what means is that we are not teaching reading material, just providing a lesson by talking. We are making the students practice, do what they have learned on the material, on the teaching material. Is basically a set of exercises that the student has to do. By doing this, the student is reading something and then practices at the same time and seeing the result almost in real time. What we are doing by doing this is that we are reducing the delayed reward that we talked before. Then finally, on the fourth step, what we do is the student has to practice constantly. So it's learning by doing. Okay, so far so good. So here we have the method, and now we are going to move into how to implement this method. I would like to know if there is any question now in the chat. If you want to ask something up to here, or otherwise, we move to directly to the next section. Okay, no questions? Great. So moving to the next section. Then, how to implement the method. I'm going to show you the method that we call the NASI method. in order to teach ROS, what we propose is that you base your teaching lessons in notebooks and simulations instead of using just the slides. That is a typical method. The teacher that is teaching ROS just go there to the class and then has a bunch of slides. It shows one after another, and then he goes home, and the students get confused. So instead of that, what we propose is that you use notebooks. It means Python notebooks and simulations. That means Gazebo simulations. By using this, the steps required to create a course using this methodology is composed of the following. First, you will have to create the syllabus. That's the material that you are going to teach, including the exercises and the practices that the student has to do all the time. Then you will have to create the simulations. You will have to provide the student with some simulations to practice with. And then you will have to provide access to all the students to all this material. The syllabus that is created on the notebooks, then the simulations that contain simulation of the robot. Then you have to provide that to the students so they can use it, they can reproduce it, they can execute in their own computers. Great. For that, what you need is to install several stuff, either in your computer, in the student's computer, in the computers of the lab, of the school, university, and of course, the typical ones, Gazebo as a simulator, Jupyter as the one that is going to handle the notebooks, and ROS, that is the glue. It's the glue between all of them, but also is the subject that we want to learn. We want to teach to the students. So for the creation of the syllabus, we are using what we call Python notebooks. If you don't know what is a Python notebook, it's a web page where you can embed text explanations with code using a web browser. And this is provided by Jupyter application, by the Jupyter application. So you look for Jupyter. I will provide the links for accessing Jupyter in the description of this video once it is online. But basically, that's a notebook. So you can edit this text that it contains the notebook. You can add a lot of stuff that we are going to see just right now. And then you can provide that to the student that can run this in his own computer. And okay, why to decide to use Python notebooks? Well, first, we use Python because teaching ROS with Python is a lot easier and faster. So we know how to program ROS with Python. We know how to program ROS with C++, and C++ introduces a lot of extra overhead that is not necessary to introduce right now at this moment when the student doesn't know anything about ROS. So what we propose is that you start with Python because it's easier, and then once the student understands the whole concept of ROS, how it works, topics, packages, etc., then now you can tell, oh, okay, so what you have learned with Python, then with C++, it works like this. And that's it, because then the student will be equipped with a lot more of knowledge in order to attack the problems that appear by using ROS with C++. Okay, so second reason is that the notebooks, as I explained before, they allow us to embed code in them. So it's not just that we are writing code on the text, it's that this code can be executed inside the notebook. That's amazing. Don't you think? It's amazing. So you can introduce code in the explanations that you provide to your students, and they can execute that, or maybe you can make them modify that code in order to do something or do something else. but you are providing all that code that is ready to be executed on top of the notebook. Finally, the notebooks are also allowed to create data on the fly. It means that you can use the notebook to capture data from the simulated robot and show it on the notebook in real time. So as you can see, the notebook is not something that is like a book written in a web platform. It's nothing like that. It's something that is alive, it's dynamic. It can change in real time. And that is very, very powerful in order to teach ROS to students. Okay, and what else? Let's go for the next section. So in order to launch Jupyter, once you have installed into your computer, you just type in a shell of the computer Jupyter notebook, and then it will appear. The program, it will open directly into your web browser. So you can have it there. And one thing that you have to be sure is to check that your notebook has, your Jupyter has ROS support. So why I'm telling you that, because sometimes you forget to configure properly the shell from which you are launching this command, the Jupyter notebook command. So you have to take that into account and configure properly your shell in order to be able to do a simple import ROS.py, like you can see here on the image. Import ROS.py. So if you cannot import ROS.py into your notebook, your student will not be able to execute ROS code there inside the notebook. Okay. So another thing that I would like to tell you about the notebooks is that you can embed some text. So you just select the cell of the notebook and then choose the type to be Markdown, and then you can write your text. As you can see in this picture, you can see that there is a title, then an explanatory text, and you have many other subjects, many other types of text that you can do by using Markdown language. Then also you can, of course, embed some code. You can embed shell code, that those are commands that are executed on the shell of the Linux shell of the system. Or you can embed Python code like this one, as you can see here also on the picture. And this code, as I said, is executable. At any point in time, you can select this cell that contains the code and then press the play button, and the code will be executed. This can be done by the students themselves and check what is the result, etc., etc. You can also embed some graphics. So by using this command inside a cell, you can embed some expected results. For example, this is for the movie setup assistant, and we want to indicate, hey, if you do this and that, then this window should pop up with this information. So you can embed pictures, and of course, you can also embed videos. You can embed videos from YouTube and also from Vimeo. It is possible to do it. I'm not going into the details of how to do that, because all that information is included into the PDF that you are going to receive at the end of this webinar. So just to let you know that you can do that. This is extremely powerful for creating live notebooks. And more important than pictures and videos are real-time figures. This means that you can interact with the current simulation that is running in Gazebo in the same computer that you are running this notebook. Request some information using, for example, ROS subscribers. Get that information and then show that information in real time inside the notebook. That is amazing. That's an example of this figure here, where there is a robot that is sensing different obstacles with the different sonars. So this representation here has been calculated on real time based on what the robot was suggesting. And then this image has been produced in real time. Amazing, isn't it? This is extremely powerful because you can make the students do a lot of experiments, see the results, even without having started to create packages or external files, you know, that this increases the complexity. So by using this, you are decreasing a lot the complexity of learning ROS. And finally, you can include widgets. Widgets are embedded action parts that you can use to interact with the simulation, interact with the robot. For example, in this case, this has been included some sliders that when you move it, then the robot will translate to one direction or rotate based on the value that you select on real time. So you can make the students interact with the simulation without having even to write the code, so they will understand what is happening before they have to program it. That's also extremely powerful. Okay, so up to here, I have explained how to create the syllabus of your course. Remember, the steps required are first to create the syllabus, then create the simulations, and then provide access to the students of the whole material. So just to summarize, to create the syllabus, use the Python notebooks, and you have all those options: embed text, embed code, embed images, and embed real-time figures or widgets that interact with them. Okay, so now the next step is to create the simulations. So in order to make the students practice, they will have to have some robots to practice with. And because it's almost impossible to have a robot for each student, and also even if you can have that, you will not have different types of robots, and so they will only be limited to one single type. With the simulations, you are unlimited to the robot that you can use for teaching or for learning ROS. So what you can do is to use the simulations, and for that you have the option to build yourself the simulations, or you can download them from the many repos available in the world. In our case, so we are providing this public SIMS repo that you can check, and there we are putting all the simulations that we use in our courses and platforms, and they are open source. So you can download them, and you can be sure that they work with Gazebo 7 and ROS Indigo. Some of them will also work with a kinetic game, ROS kinetic game, but we cannot ensure that. The only thing that we can ensure is that they work with ROS Indigo Gazebo 7 version. So if you want to have a look, just copy this address and have a look. I will also put this address on the description of the video for easy access. Now you have the syllabus created, how to create the syllabus, how to create the simulations, and now this is how we propose you to organize the courses. When you create a course, what we suggest is that you organize into different units, and each unit should work with a different robot. Even if the concepts are related from unit to unit, what we propose is that you use a different simulation for each unit, so the student will be able to see the different concepts using different robots. This is also in order to enrich their learning experience and also increases the speed at which the student will understand the concepts. So the units should contain some descriptive material, text explaining things, but what it should be mainly focused is on having practices. So what we suggest is that those units, they do, of course, explain something, some material, but they mainly want the student to practice what it has been explained. So what we do is that we create practices around the explanations that we provide. So our schema is explanation, short explanation, practice about that. Another short explanation, practice about that, and so on, so on. But not only that, we also create a whole project that affects all the units. So let me explain about the project. So if the practices are like small exercises related to every small explanation inside the unit, the project is a whole robotic project that has to apply all that is taught in all the units. So for example, if we are teaching ROS navigation, we'll have a unit that talks about how to create a map. There will be another unit that says how to create a path planning, how to avoid obstacles, how to localize. Okay, so this is for each unit, and then in each unit we'll have practices. But in the project, what we say is, hey, you have to build some programs that make this robot here from Robotnik to navigate from this area to this area, patrolling all the time, non-stop. So in order to do that, the student will have to apply what has been learning in all the units. I hope that the project concept is understood because it's very important. It's the one that integrates all the knowledge that has been taught into the different small parts. Then finally, we suggest that you provide an exam, and that exam should be something similar to the project. Something similar. The exam is necessary. You have to evaluate your students, and it's also a way to learn. To do an exam is a very nice way to learn, because under that pressure is where many things of the learning, they solidify in the brain. So you have to provide an exam. What we do is that we create an exam that is very similar to the project. So instead of using this robot, we'll use another one. Instead of using this environment, we'll use another one. Instead of patrolling, he will have to follow a person, or I don't know. So quite similar to the project. So if they understood the project, they have to be able to do the exam. Great. So let me show you now some implementation options that you have. So we have everything. Now we have how to create the syllabus, how to create the simulations, and how to organize all that material. Now you have to provide that to your students. So what options do you have in order to do that? So you have three options. Basically, you can create everything by yourself. The notebooks, the simulations, and the system to provide that to your students so that they can execute. Okay, that's an option. And if you have time, then go ahead. It's a ton of work, but you can do it, of course. Then the second option that we provide is that we propose is that you only create the notebooks. And then for doing that, what you can do is to use the ROS Development Studio. In the ROS Development Studio, you can see a whole environment that is already provided on the web that contains the simulations of many different robots. The only thing that is missing is the notebooks. So by using the ROS Development Studio, you can provide already the material very, very fast and very easy to your students, because they only have to use a notebook in any type of computer. they access this address, so they have access to this simulations and your notebooks. So you only have to create the notebooks. So let me show you how does it look, the ROS Development Studio. Let me switch to the different screens. Just a second, because here I have to change from different, indicate that I have to show a different screen, application window. So here it is. So this is the rds.theconcertscene.com. I'm already logged in. You can create a free account and work with it. And I am in my private zone, but I'm going to move into the public zone. And here you can see that we have many different simulations, and more are about to come. So with different types of robots, drones, ball type robots, four wheels robots, arm robots like this one, typical kabuki. And in order to launch a simulation here, you only have to press a button and then press run. That's it. Now you will see how it appears, our development environment, in just a second. And you will see, here it is, that we have here the Jupyter notebook that is been loading. Here it will appear the simulation of the kabuki. And here we have an integrated development environment, even an IDE. You can configure this in many different ways. So in case that you don't know what is the ROS Development Studio, please give it a try. And here is the notebook. As I explained to you, is the same as I've been showing you, with some commands that you have to do, some explanations, practical examples, pictures, example. This is just an example, but you can create your own here, just here, by editing the files, the cells, you see? Here you have the whole development environment where you can develop, and the student can develop the code, the URDF, the Python files, etc. Then you have the simulation here, and of course the terminals that allow you to interact with the simulation, compile programs, launch them, etc., etc. So if you use the ROS Development Studio, you have the whole environment using only a web browser. So the student can access that from anywhere. And you only have to create the notebooks. Okay, great. So far, so good. Then let's return to the presentation. Then that's an option. So first, you create everything. Second, you only create the notebooks. Or third option, you just focus on teaching and you don't create anything. You have everything provided: notebooks, simulations, environment, how to access, and even have an access to a control of the students, what they are doing, how much lessons they have learned, etc., etc. And these can be accomplished by accessing the Robot Ignite Academy on this link here. Let me show you how it works, how it looks. So the Robot Ignite Academy looks like this. Let's switch to my browser. Here, if we go to the Robot Ignite Academy, it looks like this. This is the Robot Ignite Academy. And we have many different courses already created and made for you and your students. So what you can do is to provide access to your students to this academy, and then just follow the different units with the different material, and you act as a teacher by explaining what is indicated here in the notebooks, supporting your students when they are doing the practice and they don't find the solution, etc., etc. For example, this is the content of a navigation course, and we have many others about ROS, like ROS Basics, that we can also, for example, start by pressing here. So we just start, and we have something similar to what we have seen on the RDS. But in this case, the notebook is already provided with a step-by-step definition of all the material that the student has to learn. And all our notebooks have been created following this standard of not going with a big, large explanation of the whole universe of ROS, but just going with the most important parts. Okay, so here you have the first, this is the ROS Basic Unit 2, and then explain some step-by-step lessons. Here is the development environment, and here it appears the simulation, of course. So everything integrated. Great. So far, so good. Then let me return to here because we are about to finish the presentation. The only thing that I would like to say is that many universities already around the world, they are already using our academy for teaching their students at the universities. As you can see here in Germany, Japan, Spain, or Luxembourg, Belgium. Then related about how to get this PDF file, you can send me an email to this address and indicate in the email subject, I want to teach ROS fast. Then I will send you this PDF. It's more than 20 pages with detailed instructions about how to create your own notebooks, how to use the Python notebooks, etc. I just would like to finish by indicating that next week, we are doing a different type of webinar. This is a live show about ROS mastering. In this webinar, we are going to answer ROS questions live of people that have some problems. So if you have a question, a practical question about your robotics project related to ROS, you can send me the questions before, and then I will analyze your question and maybe call you before the live show, and then in order to understand the problem, and then I will answer the question live there, showing you how to do it, you and all the attendants, of course. And if you want to know more, please follow this link here. And this is going to start next week. So that's all for now. And if you want to give me some questions, so I thank you for attendance, for staying here up to the end, and I'll be glad to answer your questions. Please use the chat to answer the questions, to send me questions. Matt is thanking for us, so thank you, Matt, for your attendance and for your interest. And then Harriman is asking if we are going to have C++ tutorials. And yes, we are, but it will be by the beginning of the next year. Until the January of next year, we are not going to have C++ tutorials. Then it says, Darius says, is there any relationship between RDS and the Academy? Yes. We are the same company that we are doing the ROS Development Studio and the Robotic Night Academy. And the thing is that the Academy purpose is to teach. And the ROS Development Studio purpose is to develop. So once you know about ROS, you may use the ROS Development Studio to develop fast your ROS programs. So that's the relation between them. And the interface is very similar, because we are using the same concepts in one place and in another. Then Lagan is asking if we make a simple mobile robot or a robotic arm with Arduino, then they get more knowledge. I am right? Yes, of course. Any practice that you can do with real robots, it's even better. So in this teaching system, we don't indicate that simulations are the only thing that you need. Of course, real robots are the best. The real robots are the things that excite us the most and that make us learn the most. But this is just in case that you have the chance. So if you can have the chance to build something with Arduino and ROS, that would be awesome. Go for it. And about the cost of the C++ courses, yes, it's the same. It's just a subscription academy. So you just subscribe and have access to anything that we have in the academy. So Lagan is indicating, no, the cost will be more. No, it's not. The cost is the same if it is in C++ or Python. We don't care. We just care that you learn and that you learn fast and that you enjoy and that you want to learn more, you know, and then afterwards you want to develop with ROS. That's our purpose. So Darius is saying, I think import-export code, notebooks and simulations. Sorry, I don't understand your comment. Okay, yeah, I think now I understand, Darius. Yeah, you mean if you can import-export code, notebooks and simulations, well, with the same user, you can access one platform, the Robotic Night Academy, or the other. You don't have to create two different users. And then you can, at present, you can download the code. You can download the code from the Academy and then upload it into the RDS. But you have to do this step manually. So the Academy and RDS, they provide some tools to download your code and to upload to RDS and vice versa. At present, is not automatic, that we have a button and then it's synchronized. You have to do it manually. At present, in the close future, we'll have this close integration. Any other question? Okay, if you have any other questions, do not hesitate to send me questions through the email, and then I will be happy to answer you. Thank you very much for your attention, for coming here, for being here. Thanks a lot, and I see you on the next webinar. The next webinar will be next Wednesday. That is this webinar about questioning and answer live, and then we'll have another webinar next Thursday also. You can check our webpage for all the webinars. Thank you very much, everybody. Cheers. Bye.